Hi, I'm Abdulrazak Nasiruddin, a senior software engineer. Let's talk about web application security. When it comes to building a secured web applications, I want you to know that there will never be a point where you have built an application and it is 100% secured. There will always be one flaw or the other in your web application. But what you can do is to mitigate the level of attack as much as possible. Top software company or top social media company like LinkedIn, Facebook, and Google, for example, usually have what we call a bug bounty program. They enroll in this program. It's a kind of a special program where cybersecurity professionals are rewarded for detecting bugs in that application. And the essence of this is because those top companies believe that they can never have a system that is 100% secured. If they have done their best practices, everything in place, they need to ensure that other people take a look into it and try to figure out attack as much as possible before like a black hat hacker can come in and take over the entire system. So they pay the white hat hackers to detect the bug earlier on and fix the vulnerability as much as possible. So you can't be a professional software engineer without having a good understanding of cybersecurity to some level. And this is a mistake a lot of beginner software engineers make. Even professional software engineers make the same mistake. When building an application, a lot of focus is put into the user interface or the user experience. But other things like web application security, like are you filtering the user input? Are your DNS well configured? Those little vulnerabilities or little flaws are overlooked, and this can lead to bigger issue earlier on in your software development process. So the first thing I want us to talk about is you should never trust your user input. And never trust your user input in this sense is let's say user come to your platform, they create an account, you have a search system, you have a system where people can just type in anything, and what the user type gets to your backend. You should never at any point never trust the user input. What you do instead is try to filter out the input to exactly what you want. If you expect a number, you take in only a number. If you expect a letter or a string, expect only a string. And when a string comes in, you need to be sure it is validated and properly structured to the format you expect it to be. Most attacks are usually due to not filtering a user input. Attack like SQL injection, for example, where user is able to overcome or take over your application just by injecting some SQL queries into their payload or into whatever they are sending to your backend. So there are more practices that needs to be in place. You should at any point never store whatever is coming from the user into your database directly. You need to also ensure that as the input, as data are coming to you from the front end, are they structured in the expected format? If you are going to, let's say, make an SQL query with whatever is coming, you need to filter out unnecessary queries or an unnecessary input from whatever the user is sending. If you can do this and do it well, it can mitigate the attack as much as possible. The next one I want us to talk about is having rate limiting in place. What is rate limiting? When we hear rate limiting, it actually talks about a kind of a system where you limit how many times a particular IP address can access a single resource in your web application or your software application. Let's say you have a forgot password field, for example. When a user type in their email address, then you send them like a 6-digit PIN. So if you have this system in place and you don't have rate limiting, what that means is someone can type in another person's email address, or a black attacker can type in another person's email address. Then, because they don't have access to the email address, then they can use the automated tool to brute force your input field. So when they brute force your input field for the 6-digit PIN, even though it will take a lot of time, but they will definitely figure it out when they combine all the different numbers together and they get to the 6-digit PIN. And when they do that, they can do that for as much as account as they want, and they can take over anybody's account. But by having a rate limiting in place, where you actually know that when a user tries to access a single resource continuously with the same IP address, you can lock that account. What most companies do is kind of limit the IP address, but in this case, you are limiting the IP address. You are also limiting the account. So you temporarily block that account and ensure that the person cannot reset their password. You can lock it for like 2 hours, and the person needs to come back to try to recover the account. If you can do this, you can mitigate the level of brute force attack as much as possible. The next one I want to talk about is never keep secret keys on the client side. I see a lot of beginners making this mistake. So when you have a web application, you have a backend, you have a front end. Your application secret key, like your API key, should not be stored on your on the front end or on the client side. In this case, what can happen? There are automated tools in place that can scan a web application and pick out some secret key. Could be, let's say, your Paystack secret key, could be your PayPal secret key, could be your, let's say, your application secret key. Whatever type of secret key it is, you should never store it on the client side, because if the automated tool is able to scan the application and pick out that secret key, the entire system can be overtaken from there, and everything becomes a story. It can lead to exposure of secret information. It could even cost your company a lot of money. The fourth things I want to talk about is, if you have put every system in place, you have secured your application, you have you have done a lot of checks everywhere to ensure that your application is secured. You have the best practices. You are using the right linting code. You are using the right function declaration, variable expressions, and stuff. There's a vulnerability that is usually overlooked, and that is dependencies. So dependencies like, let's say, a node application, for example. It could be a dependency you installed from like an npm package you installed in your application. Your application is dependent on it to work perfectly. If you have done everything in place to secure your application, because you use a dependency that is vulnerable to a specific attack, it can lead to a scenario where your entire application is hijacked. So in as much as it's possible that you use dependencies, you do everything, always check your dependencies for known vulnerability. You might not want to do this yourself, but there are open source platform, or there are even paid platform that can automate that process for you. A lot of them are out there. You can make your research. So with this few talking points, I hope you are well informed on why it's important to also be a security professional when it comes to becoming a great software engineer. You can't just become a software engineer that build application but not factor in security mechanisms. And for our future video, I'll be talking about in-depth on different type of vulnerabilities we have, like SSS attack, SQL injection, how rate limiting can be bypassed. I'll be going into more details on a lot of concepts, but for the concept of this video, just going to be like an introduction, so you are well informed on how to have that mindset that it's not about having a system that works fine or that meets a specific requirement, but is it also well secured. Thank you, everyone. Peace.